All right, then go ahead and we'll advance your slides. Just let us know.
Yes, thank you, Tim. So here is a brief update on the LUCI mission. Next slide, please. So just a few remarks as an introduction here, what the LUCI mission is about. For those that are less familiar, LUCI is a tour of the Trojan asteroids, and what you see in this slide is basically the orbit of the spacecraft in green as it unfolds into the inner solar system, and this is in a frame rotating with Jupiter. So you see these weird loops because of that. The key events for the missions are indicated at the bottom in yellow. Key dates, but what's important to know about this is that we will go through first a flyby of the main belt asteroids, Donald Johanson, and then we will go through the L4 cloud, and we will have 4 flybys into section one after the other over a span of a few years, and then the spacecraft will come back into the inner solar system and then go out again towards the L4 cloud. And here we will pass close to Patroclus and Melanesius, as the little inset shows. These are, it's a binary system, and so we'll have 2 large objects at once. And the mission will end in 2033, and the nominal launch is October 21st. Next slide, please. Here is just a quick artistic rendering of our target. The artistic means that all the craters and details that you see on the features on the surface, of course, those are just made up. What's real in this chart, however, is some information about the shapes of some of the targets, particularly Oros and Eurybates and also Lucas. We have a rough idea of the shape by light curves inversions. Likewise, we have an idea of the shape of the largest, Patroclus and Melanesius, thanks to occultation. So there is a little bit of reality in what you see here. What's more important to realize is the relative scale of the objects and also the relative coloration. As you'll see, there are some that are gray, some that are redder, and this is to mimic what we actually know in terms of visible slope and also near-infrared spectroscopy. As you see, the target, some are C types, some are D types, P types. That's of the spectroscopic jargon, but what it means is really there is a difference in slope and colorations. And so it will be extremely important to look up closely. What we try to do here is cover both swarms of the Trojan clouds. We want to understand the collisional evolution of these objects and also, you know, the composition. So some more details in the next slide, please. First thing to point out is that there is about a ratio of 160 in terms of mass between Patroclus and Polymele. Patroclus is actually the largest Trojans, and Polymele is only about 20-25 kilometers across. And so what this tells us is that we will really be able to sample a great variability in terms of mass of these objects, which is important in order to unravel their collisional evolution. Next slide, please. Yeah, here you see some additional details, starting with Eurybates. Eurybates is actually extremely interesting because it is the largest remnant of a collisional family in the Trojan clouds. And so we will have an opportunity for the first time to look up close a largest remnant of a collisional family. Polymele, it's very small. It's thought to be certainly a fragment of a larger object. So yet again, we will study the collisional evolution of these objects. And furthermore, finally, with Patroclus and Melanesius, current understanding is that those are truly primordial objects. So they formed as a binary system early on in the solar system, never were disrupted by collision. Otherwise, they would not be binary anymore. And so And so this gives us the opportunity to probe really the primordial objects that were formed in the outer solar system. Next slide, please. Now, what kind of measurements Lucy will carry on? As you know, of course, Lucy is a flyby mission, and so the spacecraft carries those typical instruments for a flyby, and the things that we will try to do are indicated schematically in this chart. Of course, we are interested in surface geology of these objects, and this will be accomplished with an imager. And then we are interested in surface color and composition, and this will be accomplished by using filters in the visible range, but also a spectroscopy all the way into the infrared. We also want to explore the regions of space around the objects, looking for satellites or potentially even rings. And finally, we will try to assess the internal structure of the object by constraining their densities. Next slide, please. Here you have a picture of the actual spacecraft. I mean, of course, it's rendering, but it's the most updated rendering that we have so far. You can also see the payload, and there is an inset that shows on the left the scanning platform that brings all the instruments we carry on board. Details of the instruments can be found in here. We have LORRI, which is an imager, and then we have T2CAM that is used for terminal tracking, but also would provide interesting images for science. Then we have RUF, which would provide colors in the visible range, and also infrared spectroscopy. RUF has 2 channels. And finally, we have LTAS, which is an emission spectrometer. At the bottom left, you'll see actually the range of wavelengths that will be covered by each of those instruments. And also the chart indicates about the heritage for all these instruments. These are, for the most part, instruments that have already flown in the past, so well-tested systems. And finally, let's not forget about radio science that we used to carry on to estimate the mass of the targets, and therefore, of course, by coupling that with the volume, we will derive a bulk density. Next slide, please. Now, besides all this introduction and key aspects of the mission, let's now discuss a little bit about what we have been doing more recently. So we completed the mission PDR in September 2018. It was a major milestone, and as a result of that, the spacecraft Lucy the mission was confirmed in October the 30th of last year, and so that was really an important step moving forward. Next slide, please. Here is an aspect that perhaps is less known about Lucy the mission. We do have a strong student collaboration that we call L-Space. L-Space is rather a large entity, and it comprises, has different parts to it, so to speak. So I'd like to spend a few words to explain those parts. At the top here, we have what we call ASU Instrument Incubator. This is an activity carried on at ASU. We currently have 88 STEM majors, mostly coming from engineering, and what they do there in the lab, they start thinking about instrument concepts, and they really work hands-on on perhaps looking at instrumentation and how that works. And then we have 2 other components. These are sort of national activities, and the first one is what we call the Virtual Academy. Here we basically have students from all over the place. As you see on the map on the right, many institutes and universities are involved with this. We have 3 open calls for every year. The numbers that you see here are for the fall semester of last year. So 385 majors were interested and participated in these activities. And then we have already the spring semester lineup, and if we add those 2 together, we end up with 685 students involved. So it's great because here they will have some team members will give talks. to the students, and so they will get acquainted with the mission, and then they are assigned to work on specific problems, such as, for instance, planning a small space mission. It could be a CubeSat or something like that. And in the picture at the bottom right, you actually see one of these groups that have been assigned to work on a mission concept. The other elements that we have is what we call summer intern program. The term is self-explanatory. We have here students coming for the summer. We can host them in various institutes. Zwier is one of those, but Lockheed as well, Goddard and other places as well. We have received so far 169 applications. This is for this coming summer. And finally, the last addition to this wide program is what we call Lucy Asteroid Ambassador Program. These are students that have completed the previous steps that could be then enrolled into do outreach activities for Lucy's and talk to more people. So this is a very active environment. And if you go to the next slide now, I just would like to point out that we are now, there's a call open for the summer virtual academy. So people can actually apply and information can be found on this website. So please, if you know anybody that's interested, forward this information. Next slide, please. Now, this is another activity that perhaps is less known about the Lucy mission. We are, as a team, actively looking at ground-based observations. And what I'm reporting here is looking specifically at stellar occultations events. On our web page, indicated here in the chart, you can actually go through and have a look at all the occultation events that are coming up in the near future or the next few years down the road. These are events that are particularly important to us because with occultation, we can provide a constraint on the size and the shape of the objects. And so all of this could potentially be folded into the mission plan if we have this information early on. So this is really of interest to us. As a matter of fact, the team deployed the first occultation of Lucas very recently in November of last year. Lots of data were collected during that time, and we're still working on analyzing that. But there are lots of other opportunities coming in the near future. So again, you know, this is something that we manage as a team. If you go on the web page, you'll find all the information, but it's good that people are aware of this because it's going to be a useful activity for the mission. I believe we are close to the end. Next slide, please. Yeah, that's Hal's favorite closing slide. So I'll be happy to take any questions.
There's questions.
We have a question online.
Can you wait for the microphone?
Sorry. So we have a question online from Carolyn Mercer that how sensitive is Lucy to the October 2021 launch, and how large is the launch window?
I believe we do have, that's the nominal, October 21 is the nominal opportunity, and then we have a backup opportunity 1 year afterwards. So we are robust in terms of, you know, launching opportunities.
And there's another online question is, has launch vehicle been selected?
There has been ongoing discussion very recently about this, and I believe all of this has been affected by the shutdown. So I'm not aware that a decision has actually been made, but hopefully we will have that information soon.
All right. Thank you very much, Simone.
Thanks.
And